Welcome to Heat Haze. I'm Rob. We're going to talk you through setting this up, what it does, and bending some light. So, what is heat haze? You probably know it's the way light bends as it passes through volumes with variable density. So, light will always bend from low density towards high density, and as you can see in these images, it gives you the mirage effects on hot roads, and distortion behind jet planes, and also distortion when looking through the heat above a fire. So the heat haze tools literally tries to emulate what goes off and bends rays as they go through a volume, trying to mimic the effect. It then measures the distance of this distortion and records it in a 2D image for you, or a parameter or an attribute, which you can then apply in post to give you accurate heat haze, which follows the flames moving through a scene, the cameras panning, rotating, doing whatever. And basically makes it look like the heat haze really does belong to your CG heat. Okay, so this is a test scene I've got set up. It's really simple. I've got a heat source, which is basically a box that's then changed into a volume fog, and I've called that temperature. I've got a wrangle to set the temperature hotter towards the bottom and no heat at the top. And I've added a bit of noise to make it a bit more interesting, and that's it for the heat. And if you have a look at the visualization, you should be able to see, again, hot at the bottom, cooler at the top, just like heat on a road in a summer's day. The heat haze plugin requires a camera. It needs somewhere to throw rays from, hence I've got camera 2 set here. And before we dive in, I'm just going to have a quick pan around this to show you what you're kind of getting out of it. So if I go to camera 2, you can see the distortion map that's generated. I mean, this is literally a plane with lots of points on it, and the points have colors as well as the iDistort values. Okay, so that's the result, the distorted image. And as you can see here, these are plotted points along the rays as they travel through the volume. If I take a look from the side, if I get the right side, which one is it? I've lost it. Set view, left viewport. And I zoom in here. You should see the rays bend upwards because the cool air's on top, and the rays want to move up towards the cool air. So let's have a quick dive into the heat haze and basically play with some of these parameters and see how it affects the way the light moves. Diving into the heat haze, you can see here, it's just a bunch of parameters, and these, I'll go through them one by one. The first, most important one probably is telling it which camera to use. If you get this wrong, none of it will make sense. You'll get rays going the wrong direction through your volume. The camera has to match the camera that's going to be rendering the image. Next parameter is the voxel scale for the intersect geometry. So this is actually used during the vex. It checks for intersections to save time ray marching when it's not inside a volume. So this is to use to convert the volume into rough geo to aid that intersection. Roughly keep this about the same resolution as your volume voxels. The next one is the gradient multiplier. The way the code works is it works out it uses the gradient from the volume to figure out which direction to bend the light. Generally, the values for the gradient are way too high. So start off with very low numbers. In fact, on the screen here, I've got 002, which is, again, that's crazy high, but it's just for demonstration purposes. And I'll show you later on sort of the values I've used in other projects. Okay, next one, background plane default distance. Oh my God, I can't speak. So the rays have to stop somewhere. Even if they don't intersect geometry, they have to stop so I can measure the distortion amount. So this is roughly where you would put a background plate if you were in comp. So I've set this to 3000, which someone told me once is a general good rule of thumb for background plates. The trace resolution is how many points it's going to fire out, and basically the resolution of the final image as well for the distortion. Yep, I mean, basically the more points you add, the slower it's going to get. So I've got it down to 720 here. I think later on, the next project I'll show you, I use 1080, but this is what basically just makes it a bit faster. Okay, after this, we've got ray step distance. This is, if I zoom in here, you'll see lots and lots and lots of dots. And this is basically the dot moving through the volume, or the trace moving through the volume. That is this distance here. Putting in a larger distance means it will calculate a lot faster, but you will lose some of the detail. But with this kind of the way the tool calculates things, the detail is not always so obvious, so you don't have to go crazy small steps. The next setting is max ray steps. This is how many steps a ray is allowed to take in a volume before it's considered basically dead. This is to stop basically rays of light looping around in circles forever and never hitting anything and crashing your Houdini. Below that, we've got Generate iDistort Limited, which is here. And now I've clicked it. I'll turn it on. So what this does, there is no distortion for the volume itself. This is just part of the paths traced through the volume. But sometimes you will see your fire or whatever heat source you've got looking through parts of the heat source. So what this does is it measures the value as it steps through the volume, looks at the values, and if they exceed this value, it'll record a point there that it'll use for a second distortion map. So this is useful if you set this value to be where emission starts in fire, and that way you should get some distortion on the flames that are in the background of your other flames. It's only going to work for the first time it hits that value on a particular path. So it kind of works, but it isn't physically accurate. But it does look better than no distortion at all. And you definitely can't use the normal distortion for your fire because it'll just look weird. All right, finally here, we've got visualize test rays. So this is these dots on the screen. So it helps you figure out how much bend you've got. To be honest, if you can see the bend, you've probably got way too much distortion. It's very, very subtle, and the actual amount of distortion is only really apparent at distance. But yeah, you can visualize them here. It's always useful if you're trying to debug, and the percentage of rays is literally how many you want to see. If you crank that up too high, you won't be able to see a thing. If I reduce this, you'll probably be able to see this a little bit better. Right, now I'm going to start messing with some values, mainly the index of refraction, so you can see what it's doing. Okay, so I'm just going to mess with a couple of values, and the rest of them are kind of self-evident. The main one I'll go for is the index of refraction. So at the moment, you can see on the screen, the camera's here, and the light bends as it goes through. If I make this larger, you'll see the bend increases. Ding! There you go. So you can see the light now comes in and bends more. So that's the one you probably want to tweak a lot. Get the amount correct in here. Don't try and fix it in post. That causes issues, which I'll explain later on. But basically, the distortion needs to match the geometry, and if you change it in post, you're going to be pulling in bits of geometry in your image that are in the wrong plane for where the actual surface is. Again, I'll try and explain it better later. Okay, and finally, I just want to show you the distortion map. So this kind of sits right in front of the camera just to annoy people. As you can see here, there are grey areas in the heat. This effectively means that the ray didn't reach the end of the trace, which is this background distance of 3000. It bent so much it went outside the field of view of the camera. One thing to remember with this tool is it's all screen space. So you don't have any information about the backside of objects if a ray bends behind an object. So there's tricks in this to keep it in screen space, which will match up for what you do in post-production. As you can see here, this is crazy distorted. So if I go back in here and put some reasonable numbers back into the distortion, you'll see, hopefully, what looks like a reasonable distortion map based on the heat that went into this. Right, next up, I'm going to open a project, which is in the video for this. Okay, this should be fairly straightforward after the last bit. It's pretty quick. Here you can see the output of the distortion. Things to note are that we've got foreground objects, and they are completely black. There's no distortion. You've got bits of crag. That's the silhouette you can see. And his hammer. Some of them are in the heat, and you can see some distortion around them. Some bits of them are outside the heat volume, so there's no distortion. You'll see in the scene in a second. I'll just pan in, and you'll see if I actually turn things on. A crag, a background, I'll turn the fire on in a second, but it takes a while to load. But if I go to cam 1, you'll be able to see where Craig was. Ta-da! And there you go. So the heat haze takes into account the placement of objects. It will work with objects that are in the fire or passing through the fire. It'll get the correct amounts, which is always good. No more messing in post, trying to mask things, scale things, all the rest of the stuff. Okay, quick drive through the setup. I've got a bunch of lights just to try and make it look almost pretty, but no effort. I've got an environment light, which I'm using for the background. The image here is from HDRI Haven, so run across, grab this if you want the same thing. If you're downloading this HIP, obviously, yeah, you need that. I've got a material node as well, just to assign materials to these things. Again, nothing exciting, just to basically colour it in a bit. Let's have a look at Craig. Literally nothing exciting. It's Craig doing his thing. I assigned a material that's a bit shiny, so it looks a bit cooler, maybe. Yep, put some velocity trail in there so I can get some velocity blur. And I output him as collision, and that's used for the heat haze. So he's part of that collision. Into the background geo. So yeah, nothing exciting. A floor and some pillars. Brilliant. Collision there as well. That's also going to go across into the heat haze. Into the fire. This is actually done using Axiom because it's cool and it's fast. So there you go. Axiom is outputting temperature, which is what I'm really interested in. There's a couple of other things going off in there. Kill that cook. I'm just doing a bit of convolve just to get a bit more interest in there because it was very rough. Outputting the temperature and also a pyro bake. This is using the heat haze tool. So let's dive in, see what we've got going off. I've got the temperature volume coming in up here. On the left, I've got my two collisions, got Craig and the Geo merged in and piped into the right hand input. And here are the settings from the ID store. So these are obviously the same settings as we talked about previously. It's pointing at camera 1. The Vauxhall scale roughly matches the temperature gradient. And let's just have a look about what's going off. So if I spin the camera out, and you will see the rays, and you'll see them as they go through the volume. Sorry, it's wobbling around, not focused on the right object. But what you can also see, if I go a little bit closer in, you'll see red points in here. This is where the iDistort limited value is being recorded. So these should tie up with the flames, or at least the very visible flames. The setting here for this is, I've got it at 27. I know that my pyro bake was set to a top end limit of 33. So this is just the really bright areas. Hopefully that'll give the fire a bit more movement later on. As you can see, the rays look fairly straight. But if I look at the camera, you'll see that there is quite a lot of distortion. Again, we've got the pillar in the foreground, which is before the volume. We've got Craig that's half in, half out. And the really distorted portions over here are actually the background plate area. So the pillar here, a little bit in the background, not quite as far, so the colours aren't as strong. The actual iDistort values down here. So the mins and maxes, 12s, 13s. Yep, 14s. Literally the number of pixels it's going to shift. Definitely recommend rendering these out. Just one frame of this, putting it into whichever post-production software you're using, like Nuke, and just checking the amount of distortion. Again, you don't really want to be changing the distortion scale in post. What you might find out is that if you do change the scale in post, a value here might actually drag the distortion for this pixel over here, in which case it's reading from a pillar in the foreground, which kind of makes the foreground pillar bend this way a bit, which is definitely what you don't want. That will break the illusion. Okay, so that's, I mean, this plane sits straight in front of the camera. Again, with the light rays, they are pretty much going straight through. You can't hardly tell. Like I say, these values are very small. It's just the distance that amplifies that angle change. So the further thing is away, the more you're going to notice it. I'm just going to take a quick dive into the heat haze itself. And so top here, we've just got our geo coming in. And the temperature coming in. I'll just sort of step through it so quickly you can see what's going off. Really, the parameters here are just passed out anyway to the top level of the HDA. First, we are generating a grid. if I focus on this, in fact, let me just pop up and get rid of things that are just going to obscure it. Go back to Heat Haze, back in here. Okay, so I'm generating a grid. This is going to be in NCD space, actually in the camera space. I'm flipping the normals because it's the wrong way around, and I'm going to project this back into the scene. What you should see is if I select the correct camera, ignoring the output, actually the right shape, which is the important part. Originally it starts off a square that's 1 by 1. Now reprojecting it back out puts it into the correct aspect ratio, all taken care of. And these are put in a group. It's just called distance plane. Right. The next part is the bit that limits things to screen space. So if I show you this, first off, you can see that Crag looks a bit rough. That's down to the resolution we used. I'm only running at half of 1080p, so it looks a bit blocky. If you've got complex geo, increase that resolution. But a lot of the time with the heat distortion stuff, you can't really tell the lack of detail, other than the fact that there's actual blockiness in the distortion itself. The geo part of it isn't really as obvious. And this is the bit that sort of takes care of the screen space. As you see, if I look through the camera, everything looks all good. But obviously we can't allow a ray to pass behind an object because that's not in the final render. And again, if a ray went from here and ended up behind this pillar, when it's used in post, it would actually sample a pixel from the pillar itself, and we'd end up with a pillar bending, which would make no sense. So the magic is this plane gets projected back out into the scene, and it gets projected and sticks to whatever it hits. So what you'll see is some weird projections. And if I just go up and get rid of the other geo, this will make a bit more sense. So you can see this projection will stop rays moving sideways behind objects. I see Crag's hand is sort of half through one, and the post is clipping for no good reason. Right, but back to the camera, everything looks fine. Again, this is just limiting to make sure rays cannot pass behind objects, just in case they end up stopping behind an object, which would cause problems. Right, further down, this is just renamed into collision. And this is also added in to the collision that's coming. There's a collision geometry generated from the volume. That goes in here. And a gradient is calculated. So over here, the gradient for the temperature is calculated. The tick box was set for use temperature, which means that later on that's going to get inverted, so it moves in the right direction for temperature. And into this node here is where all the code and stuff works. So, yep, a couple of volumes coming in, and and a collision coming in on the left. And all it's doing is just throwing these rays out into the scene. And God, that's an awful color green. The color coder to help me know, it's basically to debug it. So they tell me when things hit things. Different colors mean different things. I think I did put a note of what they are somewhere in the code. Yeah, so here it tells you whether I'm hitting geometry, whether I've hit the volume gradient again, which shouldn't be noted really. Just general things that help me to debug. If you ever need to change what the colors look like, they're in here. This literally starts off with a ray at the camera, at that plane in the camera, picks its point, and it looks at the projected point where it should be in the distance, or on the geo, should I say, and then it starts in that direction, and it does a quick check to see if it intersects something. At which point, if it intersects a volume, it will start running through the volume stepping stuff, this ray marching bit at the top. And it'll keep looping round, blah, 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 and you will get rays that are actually bent but look kind of straight. Again, if you can see them bend, you've probably got too much distortion in. Okay, after this, it's just blasting bits out. There's an attribute wrangle here, which puts things back into the camera, into NCD space again. Well, the same projected space from the camera. And then the difference between the positions is calculated. If you wanted to output something other than the pixel distance, you could do that editing right here. You can go in here and change this to you can change the sort of outputs, let's say UV distortion, so like a new UV coordinate rather than pixels. A bit of tidy up, and out it goes. One thing to note is right here, although I'm previewing the trace points, I've got it set. Because I left it on with it when it's cached, which is fine. You just need to basically get them out of the way for when you're doing a render. They're not needed. So I'm just blasting them. They're already in a group called trace points. And I think here I'm just multiplying up the color to make it more obvious in the screen. It doesn't affect the distortion. They are different parameters, and I will show you those there. So if you look down here in the geometry, I've got an iDistort, which is the normal distorted value through to the geo at the back, X and Y. So it goes from minus to positive. Obviously 0 means don't move the pixel. Negative to the left on X, positive to the right. Same thing with the Y side of it. And we've got iDistort limited. This is again the actual fire volume itself, those little red dots that are in the volume, to give you some distortion for the fire. If you try to apply the normal distortion to the fire, it will distort far too much because you're looking through it at a long distance. So that's all this is doing here. It's just making it a bit more visible for this, and getting rid of the points because they're not needed for the render. Okay, quickly onto rendering over here. I just use Mantra because this is really fast anyway. It's literally outputting a param or an attribute straight to an image plane, so no big deal. It's nice and quick. And I'll just start that off and see what it kicks out. I should mention, for people who just don't quite know what it is, I'd set it up, should I say. I'm just rendering extra image planes. I'm not really rendering anything apart from these two extra image planes, which are the iDist and the iDist limited. I forgot to mention that inside the heat haze, there is a shader already there that will output these attributes ready for render. And it's this one up here. So just inside the heat haze, in the first material network, and it's just called iDist. It's a principal shader that does nothing more than take the attributes and basically make them available to Mantra. Okay, here we are in Mantra. Color channel no use at all, but we will get an iDist for the main distortion. Again, you can see here quite clearly parts of crag are in the heat, some parts are not. Again, the front pillar here isn't. Not quite so obvious as it was before, but there's a pillar here. It's got less distortion. And the iDist limited, you'll see, is just limited to the fire itself, just to add a bit of movement to the fire. Okay, so this is comping it up in Nuke, a really quick comp. I've got my background over here. I've got my render out of Houdini with the usual layers in it, emission, all the rest of the stuff. And over here, I've got the distortion render pass. And you can see on this shuffle node, I'm bringing in the iDist, and this one, I'm bringing in the iDist limited, which goes over to the emission channel. So if you see over here, if I plug this into number 2, you'll see just an emission channel there, but with distortion. Let's go back to here, back to 1. Yep, so all I'm doing is taking those channels out of the shuffle, copying them back into the main image as iDistort and iDistort 2. Sorry, iDistort limited on the other one. Then using that, the UV channel for the iDistort is just the iDist that I brought in through here through the shuffle and the copy. There's no offset. The scale on this one is 0.8, but let's put that back to 1 as it should be. It was 0.8 because I was blurring it and messing with that. If you're going to blur, just reduce the UV scale a little bit. It helps keep it a little bit tidier around objects if you've got them in the foreground. The other side of it is just, again, it's the distort for the emission pass. And if you watch, if I move this down, you should get a reasonable view of what difference it makes to the actual scene. Obviously on the right, you've got the distortion from the heat haze. It's exaggerated. I rendered this with probably twice as much distortion, just so it'd be clear on a 1080p video. But as you can see, there'll be sections in here, like his hammer's getting distorted over this side. If you look, his back up here is not getting distorted because there's no difference in heat up there. You'll see his thighs around his chest there, that's getting distorted. You can see the heat there, heat haze there. As the hammer comes out of it, there's actually none. Again, you can just see the difference in the main video I'll post. But it adds quite a bit of detail and quite a bit of life to it. And the fact that the camera's rotating and the movement of the heat haze is correct helps sell it as well. Okay, and this is the final comp. Again, the distortion's again double what it should be. But you'll notice it doesn't interfere with the foreground objects, and you'll see parts of Crag as they come to the foreground out of the volume that he doesn't distort it. Things further away are more distorted. If you look at the pillars in the midground versus the actual back plate, and very subtle heat haze and distortion sort of around the fire, behind the fire, and there's a little bit of distortion on the emission itself, but it's quite hard to see really. It's not always noticeable. Probably much more noticeable if you're looking through a large volume of heat before that's in front of the flames. You can use this for anything that is volumetric and has variable density. So if you have an explosion in particles, if you rasterize those, you can do light bending effects around your particles. Again, you can scale up the volumes or scale up the P scale on those. Anything you can do that can generate a distorted volume, a variable density volume, you can bend light through it. Hope you all have fun with it. And yeah, thanks for watching this.